Okay, we have another interesting integral here from the UNSW integration, be 2023. This was finals problem 2. We have the integral from 0 to 1 of x to the 1/4 times 1 minus x to the 3/4 dx. Okay, and you may know where I'm going with this. I want to use my favorite method on this, the beta function. Okay, we have here our formula for the beta function, and just notice it's pretty much the same format, right, as our integral. The thing we need to do is find this exponent, z1 minus 1, z2 minus 1. We're equating it to our exponents in our integral. And once we do that, all we really need is this z1, z2, and then we're able to do this calculation to the right in terms of the gamma function. So to start, let's just try to find our z1 and z2 values. So for this first one, for z1 minus 1, we're saying that's going to be just equal to 1/4. So solving for z1, that's just going to be adding 1 on both sides. So that's going to give me 5/4. And then doing the same thing, we need to find our z2 minus 1. That's going to be equated to 3/4. Again, adding 1. My z2 value is going to be just 7/4. So then coming over here to our solution, I'm just going to plug in now. Nothing fancy. So when I do that, we're going to have gamma of 5/4 for z1, then gamma of our z2, which is 7/4. Now for the denominator, we need to add these two. So 5/4 plus 7/4 is 12/4, or just 3. And so now the only question is, how do we calculate or simplify this thing? We'd like to turn this into a number, right? We don't want it really in this form. Well, we have a few useful formulas in order for calculating the gamma function. The first one I'm going to use, this is going to relate this to the factorial. So if we have gamma of n, and we'll say in this case for some integer n, this is going to be the same thing as n minus 1 factorial. So we can use this on gamma of 3. So for gamma of 3, we just subtract 1 and we can write this as 2 factorial. And that's going to be the same as just 2. So when we come back to this, our denominator is just going to be 2. So we'll write that in. Next, I want to deal with our numerator. So I want to deal with these two values separately. And what I'm going to do is use another formula. We have this formula to reduce the gamma function. If we have gamma of n plus 1, this is going to be equal to n times gamma of n. So let's just use this on 5/4. So if we have gamma of 5/4, I'll just take 1 less than that because 5/4 is n plus 1. So our n value is just going to be 1/4 times gamma of 1/4. And then I'm going to do the exact same thing really on 7/4. We subtract 1 for that. We get 3/4 times gamma of 3/4. So I'm just going to take all this and plug it back into our formula here. This is going to give me 1/4 gamma of 1/4 using this. And then it's going to give me this other one, 3/4 gamma of 3/4. And now I'm going to use this value of 2 in the numerator. But now what I'm going to do is just kind of multiply these numbers together and use this. So we multiply 3/4 times 1/4. We have 3/16 divided by 2. This is going to give me 3/32. And then we still have some more gamma stuff to calculate. For these two values here, these would be difficult to calculate individually. We know how to calculate gamma for like half, 3/2, 5/2. But for fourths, it's not so easy. So what I want to do for this is use Euler's reflection formula. Okay, we have our formula right here for Euler's reflection, and we're going to use this. Notice we get the same form here. So with gamma of 1/4 times gamma of 3/4, notice you could flip them and it's going to work either way, because 1/4, if we plug, if 1/4 is our z, 1 minus 1/4 is 3/4. But if we wanted to choose 3/4 as z, well, 1 minus 3/4 is 1/4. So this can be done either way. I'm just going to go with my z value of 1/4. So then we'll use this formula. We're going to have pi over sine pi 1/4, or pi over 4. But sine of pi over 4 I can write as 1 over, we can write this as square root of 2 over 2, or 1 over square root of 2. But if I bring the square root of 2 into the numerator, we end up with just square root of 2 pi. So just putting this all together, our final solution is just going to be 3 square root of 2 pi over 32. Okay, so a really good example of the beta function. We'll stop it there. Thanks everyone for watching. Have a great day.